There is no National Electrical Code, or NEC, requirement prohibiting the use of orange tape on a 277/480 volt, 3-phase service. The statement that orange is exclusively for high-leg applications is not supported by the NEC. However, the practice of using orange tape on high-leg delta systems is a common and recommended practice. In a high-leg delta system, one phase, often referred to as the stinger leg, wild leg, or high leg, has a voltage to ground that is significantly higher than the other two phases, typically around 208 volts in a 240 volt system. This higher voltage can pose a hazard if not clearly identified, as it can damage equipment designed for the lower voltage phases. Therefore, the orange color is used to clearly mark this high leg, warning electricians and others to avoid connecting standard 240 volt loads to this phase. The NEC does not mandate specific colors for each phase in a standard 277/480 volt, 3-phase system, but it does require that the phase conductors be identifiable. This identification can be achieved through color coding, tagging, or other approved means. Common color coding schemes for 277/480 volt systems often use brown, orange, and yellow for the 3 phases, and gray for the neutral conductor. However, local codes or project specifications may dictate different color schemes, so it is always important to consult the relevant regulations for the specific installation. When working with electrical systems, it is critical to understand the different types of systems and the potential hazards associated with each. A high-leg delta system is a type of 3-phase electrical service that is commonly used in commercial and industrial buildings. It provides both 3-phase power for motors and other heavy equipment, and single-phase power for lighting and receptacles. However, the high leg poses a unique challenge, as it can be easily mistaken for a standard phase conductor. To prevent accidental connections to the high leg, the NEC requires that it be clearly identified with orange color coding. In a standard 277/480 volt, 3-phase system, the voltage between any two phases is 480 volts, and the voltage from any phase to neutral is 277 volts. This type of system is commonly used for lighting, heating, and air conditioning in large buildings. Because the voltages are higher than those found in residential systems, it is important to use appropriate safety precautions when working with 277/480 volt systems. These precautions include wearing appropriate personal protective equipment such as insulated gloves and safety glasses, and using properly rated test equipment. When installing or modifying electrical systems, it is important to follow all applicable codes and regulations. The NEC is the most widely adopted electrical code in the United States, and it provides comprehensive guidelines for safe electrical installations. However, state and local codes may also apply, so it is important to check with the local authorities to ensure compliance. In addition to the NEC, there are other industry standards and best practices that can help to ensure the safety and reliability of electrical systems. These include standards from organizations such as the Institute of Electrical and Electronics Engineers, or IEE, and the National Fire Protection Association, or NFPA. By following these standards and best practices, electricians and other electrical professionals can help to minimize the risk of electrical hazards and ensure that electrical systems are installed and maintained properly. In the case of the 277/480 volt, 3-phase service, if the inspector cited the use of orange tape as a violation based solely on the system not being a higher leg delta and no local amendments or specific project requirements were in place, the inspector's interpretation is not accurate according to the NEC. While adhering to common practices is often beneficial for consistency and clarity, the NEC allows for flexibility in color coding as long as the conductors are properly identified. The primary concern is ensuring that individuals working on the system can readily identify the different phases and the neutral conductor to avoid misconnections and potential hazards. If black tape is used, be sure to label the conductors appropriately using a labeling machine or pre-printed wire markers. The labels should clearly indicate the phase designation, such as A, B, and C, or 1, 2, and 3. This labeling will help to ensure that anyone working on the system in the future can easily identify the different phases, even if the color coding is not standard. If the local jurisdiction has adopted amendments to the NEC that specify color coding requirements for 277/480 volt systems, those requirements must be followed. It is important to check with the local authorities to determine if any such amendments are in place. When selecting electrical tape, it is important to choose a tape that is rated for the voltage and temperature of the application. The electrical tape is typically made of polyvinyl chloride, or PVC, and is available in a variety of colors and thicknesses. The tape should be applied in a neat and consistent manner, with overlapping layers to ensure a good seal. When splicing wires, it is important to use a properly sized wire connector. Wire connectors are available in a variety of styles, including twist-on connectors, crimp connectors, and insulation displacement connectors, or IDCs. The connectors should be selected based on the size and type of wire being used, and should be installed according to the manufacturer's instructions. When installing electrical equipment, it is important to follow the manufacturer's instructions carefully. The instructions will provide information on the proper installation procedures as well as any safety precautions that should be taken. It is also important to use the correct tools for the job. Using the wrong tools can damage the equipment or create a safety hazard. When working with electricity, it is important to be aware of the potential hazards and to take appropriate safety precautions. These precautions include wearing appropriate personal protective equipment, such as insulated gloves and safety glasses, and using properly rated test equipment. It is also important to de-energize the circuit before working on it and to verify that the circuit is de-energized using a voltage tester. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work. Electricians are trained to work safely with electricity and to ensure that electrical systems are installed and maintained properly. Remember, electrical work can be dangerous, so it is important to take the necessary precautions to protect yourself and others. When working with 277/480 volt systems, it is especially important to be aware of the potential hazards. These systems operate at higher voltages than residential systems and can deliver a dangerous electrical shock. If you are not familiar with working with 277/480 volt systems, it is best to seek the assistance of a qualified electrician. Firstly, always verify that the power is off before working on any electrical circuit. Use a reliable voltage tester to confirm that the circuit is energized. Secondly, wear appropriate personal protective equipment, including insulated gloves and safety glasses. Thirdly, use tools that are rated for the voltage and amperage of the circuit you are working on. Fourthly, never work on a live circuit. Fifthly, follow all applicable codes and regulations. Sixthly, if you are unsure about any aspect of the work, seek the assistance of a qualified electrician. Seventhly, be aware of the potential hazards of working with electricity and take appropriate precautions. Eighthly, never work alone on electrical circuits. Ninthly, keep your work area clean and organized. 10thly, inspect your tools and equipment regularly to ensure that they are in good working condition. Remember that the National Electrical Code, or NEC, Article 110.3, requires listed or labeled equipment to be installed and used in accordance with any instructions included in the listing or labeling. This means that any equipment used in the electrical installation must be used only for its intended purpose. In regards to conductor identification methods, the NEC Section 200.6 covers identification of grounded conductors. Section 210.5 covers color code for branch circuits. Section 215.12 covers identification for feeders. Section 230.56 covers service conductors. Section 250.119 covers identification of equipment grounding conductors. Section 310.110 covers marking. These code sections provides the requirements for identifying conductors in electrical systems.